Hello, hi. Yeah, thanks a lot. Thanks for your interest. My name is Kiran Garimella. I'm a faculty at Rutgers University. This is the State University of New Jersey. This is joint work with the folks from IIIT Hyderabad, led by Anmol and Pratyush, who are the joint lead authors on this paper, and supervised by Professor PK from IIIT Hyderabad. This is published in KDD 2024. Yeah, so the topic of discussion or the topic of the paper is about analyzing television discourse using multimodality. I'll give you examples of what these signals are, but the idea is not just considering television as a textual source, but actually making use of multiple modalities from the medium. So a quick introduction to why television and why television data is useful. Firstly, okay, television is still a very, very important medium. Like tens of millions of people, if not hundreds of millions of people, still get their information from television. Television has had a huge role in the spread of information in general, because it's a very good broadcast medium. But all these things about polarization, misinformation, a lot of the those are also established and have beliefs established because in mainstream media because of television, because it has this sort of legitimacy. Television data, when we're talking about computational social science, the lack of access to data and things like that, television data is really structured, high quality, and is openly available on YouTube, for instance. In terms of completeness, it's really complete. Like almost all popular TV news channels upload most of their programming onto YouTube as either live streams or complete shows, which are downloadable and accessible for research through the YouTube API. The YouTube API is really good. So that's one reason, for instance, why television data is important. Obviously, television is still a very, very important source. One of the limitations of the existing setup in researching television is it has been mostly considered as a textual medium, right? Like, so most of the cases when television data was analyzed, it was considered as a textual medium where you extract the transcript and you do some analysis on top of it. Like most of it is just about coverage and things like that. And obviously that is a limitation because that really limits your view on what you can do with television data. Television data is so much richer. So you have things like images, audio, video, and so on, and text, obviously, that communicate things like emotion, tone, representation, and things like that. Particularly in this talk, we're going to focus on television news debates. This is a form of television news reporting that is very popular, where you have a host and you have guests invited in the show, and they come together and discuss and debate a topic. Basically, what we want to do is we want to identify various things like who is represented, how are topics being covered, like what is the bias in there, what is the quality of the discussion. There's a bunch of questions that we want to answer based on these sorts of television news debate data sets that are available openly. So let's talk about why the sort of multimodal aspects are important and what these multimodal aspects could be. So firstly, this is a screenshot from the Tucker Carlson show. It's a very popular TV show that was just canceled last year. It was on Fox, and it was one of the most watched TV shows in the US. So if you take an image frame like this, a screenshot from a video of the Tucker Carlson show, each frame communicates something. So here, for instance, you have, you can detect faces automatically. You can detect this face, and you can say, oh yeah, this is. You can match it to known face and say, oh yeah, this is Tucker Carlson. The gender is male, and the emotion in that face is angry, or whatever. Emotion detection works quite well, especially for this quality, this type of data, which is very structured and very high quality. You can also say, okay, there's another person and their gender is this, their name is this, and their emotion is this, and so on, right? Like, so you can automatically detect most of these. You can also get the text from there, where you can say, you can use OCR to get the text, and you can say, okay, here, the topic of discussion is about January 6th. Then you can also extract the audio or speech and do some sort of transcription from it. Like you can say, speech to text using open source models like Whisper, and that enable you to say, identify what is being said, right? Like, so what was the topic of discussion. Finally, you can use this thing called diarization, which is looking at speaker turns. So you can cluster the voice signal and identify who said what at what time. So you can say from second T1 to time T2, Tucker Carlson said this. From T2 to T3, Candace Owens said this. From T3 to T4, Tucker Carlson said this, and so on. So if you put all of these together, so we were talking about image frames, text, and audio signals, right? Like, so if you put all of them together, for each second, you can really tell, okay, who's speaking using the diarization, what they're speaking using the transcription. You can look at what is being shown on the chyron, right? Like, so that represents the information that is being displayed to be communicated. Then you can look at like the facial features, like who's being represented, like, is it men or women? Is it, the guests who are being featured? What guests are being featured with what size? What are their emotions at each time interval? Like, so you can have this sort of very granular analysis, right? And so that's one part of really bringing together these multimodal data sets. The other thing you can do is you can do meta-analysis of like quality of discussion, right? Like, so because you have this voice signal again, you can detect, are they speaking in turn, right? Like, so one speaker talks and then the other speaker talks, or is it going to be a lot of overlap? Like, are they really, arguing with each other and overlapping their speech, which is a sign of a bad quality of debate. So we can do this sort of automated overlap speech detection. We can also do other things like emotion from the voice. Like, obviously, if people are speaking very loudly or shouting or talking emotionally, you can detect that automatically. You can also detect, like, from the transcript whether they're using any toxic language, like, hateful or insult, things like that. Like, so this can already all be done. So if you put all of these together, in this paper, we are specifically interested in extracting insights from TV news debates that consider all modalities, so text, images, audio, and video together, and provide insights. So we are specifically looking to answer questions like these, things like, what is being discussed? So the coverage bias, for instance, who is in the discussion, who are the guests being invited, what is their gender, what is their political affiliation, how is the discussion happening, things like, is the discussion of good quality, are people shouting at each other, like, is there a lot of arguing? And then because we have complete data over time, we can look at trends over time and things like that. So the data set for this comes from a popular primetime debate show in India. This is one of the most watched shows with over 5 million daily viewers. This is a primetime slot. And for this show, we have a complete archive of over 3,000 videos spanning over 6 years. So this is the primary data set that we used in the paper, but we also compared this with other shows from various other channels like MSNBC, CNN, a French news channel, Sky News in the UK, and US presidential debates, and so on. We have other comparisons. I'm not going to talk about that in this presentation, but this is the primary data set. And again, like the objective is to understand the quality of the discussion. I'll show you a few results that discuss this quality and representation of who's represented and what is the bias in there. So let's get into the results. So the first result is about who is invited on these discussion panels, like what is their representation in terms of political affiliation. So basically, because we can identify the faces, we can identify the names of people invited automatically. You can do this at scale, like where you can say, okay, this is a person being invited, and you can identify their political affiliation automatically. We have some techniques in the paper using LLMs. And based on that, we can identify, what is the, who is invited to these discussions. So here I'm showing you a plot where the x-axis is the topics that are being discussed. These are extracted automatically from the transcript. And on the y-axis is the fraction of guests that are pro-government and pro-opposition. So if the fraction is close to 0.5, that means that there are equal representation between pro-government and pro-opposition. If the fraction is more than 0.5, then it means that there's more pro-government than pro-opposition. So here you can see that for almost all topics except the one on the left, sports, there seems to be, the red bar seems to be larger. This means that there are more ruling party supporters who are on these discussions, and most of the topics, specifically on the right, Bollywood, Pakistan, education, so on, are really biased. Like they have 70, 80%, even 100% only pro-government debaters or participants. So this means that there's majority of the topics have pro-government supporters. So there's clear bias in terms of who is represented in terms of political leaning. The other way of representation is gender, like, what is the gender distribution? Again, here we consider it as binary gender, male or female, and we plot this over time. So we look at how many faces of each gender is appearing per each day, and then aggregate this across time. And we see that consistently over time, even like there's, the number of men who are invited is around 4 times as the number of women who are invited, and this trend persists over time. So, women are highly unlikely to be invited to these debates. The next result is about incivility, which is about overlapping speech. Like I said, like, are people speaking in turn, or are people speaking over each other? So I'll show you an example. This is just a 10-second clip that gives you an example of how bad things are. Again, a lot of these are really, I mean, you need to see these examples to understand the importance of these research questions. Again, this is a prime time show that is the most watched TV show in India. So I'll show you an example to see how bad it is.
I don't know whether you know something, Surajpal Ammo, you are a threat to the country. I don't know whether to take you seriously for your violence or for your comedian skills. Now listen to me.
Okay, so that showed you, right? Like there's 3 people speaking, everyone is shouting at each other, everyone is speaking over each other. And that's overlap speech. So how often does that happen, right? Like, is this common? So what we did is we plotted on the y-axis is overlap fraction of video. So out of all the videos that we have for that show, what fraction of videos have this sort of overlapping behavior? So that's what we're plotting. And this dotted line here is the average. So an average around 15% of the debates have at least one instance of such overlapping of speech. This means that there are people talking over each other. Again, like this is a primetime debate, a primetime news show should be of high quality, but 15%, there's 1 in 7 shows has this sort of behavior. It's really bad, right? Like, and we can do this particularly for each topic, right? Like we can say, okay, for this topic, what is the overlap? For this topic, what is the overlap? So here I'm showing you the top 5 topics and their overlap. And you can see that certain topics, even close to 20% of the discussions have some sort of overlap. Some of these are very polarizing topics. They're about a terrorist attack in India and things like that. Again, that 1 in 5, if debates having this is really indicates these are really bad quality debates. Okay, the next thing we talk about incivility is this concept of shouting. Like, is someone really talking at an increased voice? Again, you can do this automatically using the speech signal. Let's look at an example to see what this shouting looks like.
I have a question for you, Uzma. I am coming to you, and my question to you is this. Listen to the question. Listen to the question, Uzma.
You have absolutely no idea of what's going
on. Okay, so as you can see, this is that woman there was shouting, and this is around 9% of the videos have at least one instance of such shouting behavior. This is just really surprising, right? Like, so and again, per topic, if you take this, these are top 5 topics in our data set. We have this for all the topics in our discussion, and you can see that certain topics like Kashmir or religion or crime and justice, they have much more, like up to 10%, 13% of shouting involved in them, which is again really surprising. And the final thing we do is toxic speech. So this is you get the transcript and you run it through some sort of state-of-the-art hate speech and insult detection. So this is a Perspective API from Google. And so the results here are that roughly around 2% of the debates on average have some sort of like toxicity. Again, like 2% might seem like a low number, but this is prime time TV news, right? Like, so millions of people are watching. So that's a really, I think it's a really high number. So, and for some topics like, Pakistan or terrorist strikes and things like that, it goes up to even 5-6%. So that's also very sad. Okay, so there's a lot more results in the paper. One is a thing that I mentioned earlier, which is generalizability. So I showed you only results from this Indian news show, but we compare with these other shows from other contexts and show how these numbers actually are placed in context. And we also have some results over time because we have the full show, like full data set. The other important thing, we have a discussion on how the applicability of these methods. So this is not specific to Indian news, is not specific to TV news debates. These techniques of like whatever we are doing with this sort of like, image, audio, text, and combining them together are really common to other types of modalities like, television news in general, but television shows in general, right? Like where there's very clear audio signals, there's very clear video and visual features and text involved. Like these really work quite well, the existing models. Most of the code models that we're using are open source. Almost all of them are open source. So this can easily be replicated in even not just even for television, but for like, budding mediums like podcasts, like where you can also use voice, and most podcasts also have a video associated with them, so you can do some sort of large scale multimodal analysis. So that's it. Like, you can find the paper here. You can find the code here. So the code is like really well, I think we've done a lot of effort to make sure it is generalizable. You can give it a video and it'll YouTube video link and it'll directly give you an output. You can easily customize the code. So the code is available here. If you have any questions, yeah, reach out to me here. And then we also have a demo that we've built from just running this on a YouTube video for a specific debate. Again, this can be generalized, but this is a live debate that so this is a full length, like a 1 hour debate. But we can see as the debate is progressing, how much things like foul speech, overlap, and shouting are happening. Right, like things like overlap, for instance. Okay, if I let you listen to the audio for a second. So as you can see, there was a lot of overlap, and you can see these sorts of peaks here that indicate that these are the portions where there is overlap. And this we can detect like, very quickly live using the actual voice feed, right? Like so, and if you look at examples here in this video, there's at portions of it where there is also examples of foul speech. So for instance, if you listen to a few seconds here, there are going to be instances of someone insulting someone else or someone shouting at someone else that are being detected here. Like so that is also captured by our model very easily. So if you can play with that, play around with this. This is a live demo. This is hosted on my Amazon server. You can go to this URL to check this out if you want. Another thing is this also works not just for English, but because Whisper is multimodal, multilingual, it works. I mean, this is a Hindi video, and Whisper automatically takes does the transcription, but also does the translation for you, gives you the English transcript, does it also on Hindi. So these tools work not just for English, but also for other low resource languages. So that makes it applicable much more broadly. Yeah, so if you have any questions, like, yeah, reach out to me. Obviously, I'm not the one who did most of this work. It's Anmol, Pratyush, and these other students who've done most of the work. Yeah, happy to answer any questions, and thanks a lot.